Okay, now let's discuss about next bar PYQ. Just a minute. Yeah, okay. So here we have been given one question like draw a cantilever with a point load at some distance from the end. Fixed end it would be, not the free end. First. Okay. So here we will draw the cantilever. Okay, fine. We just name it A, B, and some distance from the end. So let us say this at point C. So we might assume that it was load P. Now we have to draw the deflection curve. Okay. So for deflection curve, as there is no force in section BC or CB per se, so it will be deflecting like this till here, and from here to here straight. I hope you got everyone a bite. I will draw a bit exaggerated here. Wait. Okay. Now we may think it like this. Okay. There, like this. This would be the deflection curve. The deflection here would be delta. Okay. And now here we will draw the SFD. Okay. For the SFD analysis, I will say that reaction at RA from the equilibrium conditions would be equal to P. And we are saying the whole distance as L over here. And let's say this distance is X over here. So moment at A will be equals to Px. Direction we will see later on. It will be I guess anti-clockwise in direction. Now as we go on drawing the SFD, we will draw a hash line. Now here it would be P. Okay. Up till here it will be constant, then the downwards P and up to 0. So these are point A, C, and B. Now if we go and draw the BMD here, for the BMD we will directly use dm by dx equals to V. That is quite easy. It will be like, just increasing straight line up till here. Then will be like this. Person, B point. Sorry, my mistake. Okay, I think I'm sorry for that, but my mistake. Yeah, so it will be extremely sorry. I consider it as a simply supported. Hmm. Since this is anti-clockwise, so we will start with here is Px or per se minus Px. Okay, from now onwards, it will rise up till here. Okay, and at point C, it will be 0. Yes, and just we will check M at B. It will be yes. Okay. So it will stay like 0 here. So this is point A, C, A. This was a pretty straightforward question. Just you need to know the basics of SMD and BMD. So they might ask you the extra questions here, like the load is acting at C here. Now how you will find the deflection at B? Okay. So for this, there is simple one analogy. There are various methods to solve. I will just tell you one another method here. Okay. So deflection at B will be equals to delta C plus, so this distance is L minus X into theta C. You might use this equation to solve here, like directly. Delta C formula, you know, PL square upon 2 EA. Sorry, I'm sorry. PL square upon 2 EI, I'm sorry, extremely sorry. And theta C, you will be knowing by directly for the by the formula. So you may do it like this. Thank you. Okay, so as we saw here, this question, there are more counter questions to this. Now here they might ask you that will the slope at both the ends B and C, sorry, at both the points B and C will be same, just point B and C. As we can see, yeah, from B to C, it will be a straight line, no curvature. Hence, we can say theta C will be equals to theta B. This is the main observation here. Okay. There is one addition to this. They have asked here to draw a UDL now, same cantilever. UDL with load W, Newton per mm, yeah, yeah, like that twice. So we may say A and B here. Now we have to draw SFD here. For the SFD point of view, we will just find out here the length is L. Okay, just a minute. So RA will be equals to W into L upwards. And for MA analysis, MA will be equals to the anti-clockwise in the sense. It will be so, so L by 2 into 1 by 2 into WL, which is omega L square upon 4. Anti-clockwise sense. Yes. Let me check it again once. Here it will be W into L. Yeah. So it should be W into L over here, and this length is L by 2, L by 2. So M will be equal to WL square upon 2. I'm sorry here, my mistake. I guess some confusion here, sorry. Yes. Yeah, okay. Fine, got it. These kind of mistakes are unavoidable. Sometimes due to pressure and sometimes lack of concentration, it may happen to you. It should be omega L square by 2 here. Now, if we go and plot the SFD first, it should be RA, which is W into L. Okay. Now, always see here, this is UDL since like this. Okay. Now, uh, it will vary in a linear fashion. Okay. So, it will be like this straight. I'm sorry, this is really linear. Okay. So, it will be like this. It will be this. This will be point B. This is point A. Okay. And this is W into L, the maximum load possible. Yes. Now we will go and draw the BMD here. The BMD will be like this is since anti-clockwise, so it will be starting with negative sign here. Okay. Now check it here. This is varying how fast then slow. Like fast then slow. So at point B, anyhow, it is going to be 0. It will be like a parabolic spandrel here. So it will vary like this. I'm sorry. My drawing is not that good. Okay. It will vary a parabolic. This magnitude will be omega L square by 2. Okay. So this was the another counter question. And now they were asking to merge both SFD. The initial SFD of us was here, as we can see, this one. This load was P. Okay. So here we can just show them. So it was like this. And now in this case, it is like this. It depends P and omega L, which is greater or which is not. Here I am considering, sorry, W into L is greater than P. So it will be, I am changing my color here. Go with the yellow one. So you might, both are the same lines on the same spot, just I'm showing sideways here. So it will vary, sorry, it will vary in this fashion. Like this. Sorry. This point is A, this was C, and this is B. So this is how SFD merging will be done. And for the BMD also, we may write it like that. Initial BMD was simply, just triangular here. We merge the BMD here. And now it is something like this. So initial was P into X. Now it is omega L square by 2. Something like this. Parabolic spandrel. Right. So yeah, we have answered there both the counter questions. And this was bit quite on basics and was checking your calculation skills and understanding of SFD and BMD. Thank you.